what we're now going to look at is just equations which aren't actually quadratic equations, but we can turn them into quadratic equations. So ones like this, where you'll notice the powers go down by an even amount, there's a nice pattern to them. We can turn this into a quadratic, because if we wanted to, we could replace the pronumeral. We could say, oh well, let's let m equal x squared. And if that's the case, m squared must be x to the power of 4, so we have a quadratic. That can be factorised, m minus 6, m plus 2, and we can solve that, m equals 6, m equals minus 2. But of course we just said m was x squared. Now whether you physically use the pronumeral m, I mean some people just look at it and say, oh well the pronumeral is x squared, and go straight to the factorisation, x squared minus 6, x squared plus 2. It doesn't matter which way you approach it. I suppose the main thing is coming down to these possible answers. So if x squared is 6, x of course is plus or minus root 6. X squared is negative 2. Well, that doesn't have any real solutions. So the only solutions for this one, x equals plus or minus the square root of 6. Another common type of equation you might have seen is this type of exponential equation. For multiplication, you notice I've used parentheses. Sometimes you see it where they use the dot multiplication. And you've got to be careful with that. Think about it logically. If you saw this question as 9 to the power of x minus 4.3 to the power of x plus 3 equals 0, which is what it looks like when they use the dot multiplication, you have a little bit of a rational think about that. Think, well, hang on a sec. 9 to the power of x, 4.3 to the power of x? How on earth am I going to do that? So it's not 4.3, it would be 4 times 3 to the power of x. As I say, I use parentheses, and that way there's no confusion. So in this case, my pronumeral is 3 to the power of x. So if I let m equal 3 to the power of x, then, well, m squared, eventually I could show, is 9 to the power of x. Now, I've gone the long way around it there just to prove it, because 3 to the power of x all squared. I could make 3 to the power of 2x, which I then can make 3 squared to the power of x, which is 9 to the power of x. I suppose the quick way of doing it is, oh look, 9 is 3 squared. So if I square the bases, then that must be m squared. There's my equation. And we can factorise it, and we get m equals 3 or m equals 1. So 3 to the power of what is 3? Well, 3 to the power of 1. 3 to the power of what is equal to 1? 3 to the power of 0. So there's a handful of those ones to do.